Okay, let's dive into this. Welcome to The Explainer. Today, we're unpacking a truly fascinating architectural treatise that is completely rethinking how businesses are built from the ground up. We're looking at a massive paradigm shift, moving away from those chaotic, manual workflows we've all pulled our hair out over, toward an era where the enterprise itself is transformed into scalable, compilable code. We are literally talking about the architecture of the autonomous enterprise. Now, to really wrap our heads around why this shift is so absolutely critical, we've got to look at a number that basically haunts the startup world: 90%. Yes, 90% of startups fail. Now, conventional wisdom loves to romanticize the whole product-market fit struggle and blame failures on bad ideas. But as data from CB Insights proves, it is rarely because of a bad idea. And honestly, it's almost never a lack of innovation.
So, what gives? If it's not the idea, what's actually killing these companies? Well, the real culprit is a massive execution gap. You see it all the time. Founders build these incredible products, but then they hit a brick wall of cash flow mismanagement and the very real physical limits of just running day-to-day operations. Generating leads, chasing down those late invoices, onboarding new users, these tasks pile up so fast that the organization simply cannot execute fast enough to survive.
So here is our architectural blueprint for today's explainer. 1. The carbon node bottleneck. 2. The compiled corporation. 3. Version controlling the firm. 4. The deterministic kernel. And finally, 5. Achieving progressive autonomy. Let's get right into it.
All right, part 1. The carbon node bottleneck.
Let's take a hard look at the legacy building block of basically every traditional enterprise: you and me. In the language of systems architecture, humans are carbon-based operational nodes. And look, for all our amazing creativity, we possess some pretty severe mechanical and psychological limits when we're used as literal cogs in a business machine. I mean, we have temporal limits, right? We need 8 hours of sleep, we need holidays, and we definitely need copious amounts of coffee. We process sequentially, meaning a CEO can only really execute one task at a time. We suffer from cognitive load. By the 500th invoice you process, your error rate is going to spike. We have emotional volatility, where a fear of rejection might literally stop a crucial sales call from happening. And finally, we have frictional scaling. If demand triples overnight, you can't just overclock a human being. You have to endure a painful 90-day hiring and training process. And this brilliantly illustrates the core issue here. You have a relentless global market that operates 24/7, 365. The gap between that nonstop market demand and the limited throughput of human biology, that is the execution gap. For decades, we've just accepted this bottleneck as a law of economics, but actually, scratch that, it's really just an engineering problem waiting to be solved.
Which brings us to part 2, the compiled corporation.
To see where we're going, we kind of need to look at where we've been. For half a century, computing has been this relentless march of abstraction. Think about it. In the 1940s, we abstracted physical electrical relays into machine code. In the 70s, operating systems like Unix came along and abstracted the CPU so programmers didn't have to manually manage hardware anymore. Then in the 2000s, the cloud completely abstracted the physical data center. Every single historical leap hid the underlying complexity and freed up human ingenuity for higher-order problems. The history of computing is literally the history of abstraction. And the next great economic leap isn't about abstracting IT infrastructure anymore. It is about abstracting the organization itself. Just as Linux abstracts a computer's hardware, an enterprise operating system abstracts your capital, your customers, your products, and even your legal entities into persistent programmable objects. The entire business effectively becomes a compilable artifact. Now, a crucial point here is understanding how this differs from the software we use today. Traditional software as a service, or SaaS, is really just a passive tool. Things like Salesforce or Stripe might optimize a specific task, sure, but they still require a human to click the buttons and manually bridge the gaps between systems. An enterprise OS represents a huge shift towards software as the employee. It actively drives state transitions, it manages the entire life cycle of a process, and it autonomously executes workflows without needing a human to act as the biological API. Here's where it gets wild. Because your business is now compilable code, you can literally test it before you launch it. Instead of raising millions of dollars and just crossing your fingers that the market likes your idea, the Enterprise OS compiles a business blueprint. It runs 50,000 Monte Carlo unit economic simulations. It tests slightly varied ad costs, churn rates, and sales cycles. And if 80% of those simulated futures result in negative cash flow, the system just throws an exception. It physically prevents you from deploying a fundamentally broken business model into the real world. You fail in a digital sandbox, not in bankruptcy court. Moving right along to part 3, version controlling the firm. We can take this concept of compilable code even further. In software development, engineers use a tool called Git to track their changes, run experiments, and instantly roll back if they break something. Well, the traditional artisanal enterprise has never had an undo button for disastrous strategic decisions, but an enterprise OS natively supports enterprise Git. That means every single sales script, pricing tier, and supplier contract becomes an immutable, versioned artifact. Think about the power of that. Imagine being able to just branch your entire company to run a completely zero-risk experiment. Say you want to try a localized European expansion. You spin up a branch with localized pricing and newly translated assets. If it's a massive success, you merge it into the main company in milliseconds. If it tanks, you just hit rollback. The branch is safely archived, and your original business operations remain entirely unharmed. Okay, part 4, the deterministic kernel. As we start automating all these complex processes, we really have to address a massive danger in the current tech landscape, and that is the danger of simply plugging stochastic, hallucination-prone large language models directly into sensitive operations like finance or legal. You absolutely must cleanly separate the creative AI from the actual execution engine. Large language models are probabilistic. They just predict the next most likely word. That's fantastic for writing a marketing blog, but it is totally catastrophic if an AI hallucinates a $10 million liability clause into a client contract. An enterprise requires a deterministic kernel. Given the exact same inputs, it must produce the exact same outputs every single time, no exceptions. To maintain strict compliance and security, this new architecture mandates an unbreakable boundary between the intelligence layer and the execution layer. Your LLMs, those are your strategists and your marketers, but the kernel is your executor. If you try to build a house on a foundation of probability, it's going to collapse. Probabilistic systems generate plausible fictions. Enterprise operations require mathematical certainty. Now, what's really interesting about this dynamic is how it plays out in real time. Say the LLM decides a customer is unhappy and deserves a refund. It cannot just execute that transaction. It has to submit a formal request to the deterministic kernel. The kernel then acts as a relentless, unforgiving gatekeeper. It checks, is the state valid? Does the AI actually have the capability token to do this? Does this action violate our policy threshold? If the answer to any of those is no, the kernel tosses an exception. The probabilistic brain is and always must be permanently subservient to the deterministic spine. And finally, part 5, achieving progressive autonomy. So how on earth do you legally run a fully automated business in today's hyper-regulated global frameworks? Well, you don't just flip a switch to a zero-human model overnight. That absolutely terrifies regulators. Instead, the architecture rolls out through 4 rigorous phases of progressive autonomy. In phase 1, the AI just advises. In phase 2, it gets delegated authority over low-risk tasks, but any high-risk moves still require a human's cryptographic signature. In phase 3, we move to supervised autonomy, where humans are mostly just auditing exception reports. And finally, phase 4 is self-sustaining autonomy, where humans transition purely to high-level governance and capital allocation. The AI earns its operational freedom over time. The whole system relies on cryptographic human-in-the-loop gates. This is exactly how you prove to major regulators like the SEC or the FCA that high-risk financial decisions always maintain strict human accountability. You don't earn trust by just writing a blog post promising your AI is super smart. You earn trust by building a deterministic system that is mathematically incapable of breaking the rules. So, bringing it all together, the absolute core takeaway here is that the artisanal firm is fundamentally over. We are standing right at the end of the era where a company's growth is bottlenecked by the physical and psychological limits of its organizational chart. And the craziest part? This transition from documents in motion to state machines in execution isn't just some theoretical sci-fi concept anymore. The architecture exists today. I want to leave you with this final, provocative thought to chew on. Take a hard look at your own operations. Is your company a compiled, deterministic machine, or is it a fragile, artisanal artifact that's completely bottlenecked by human limits? It's definitely something to reflect on as we enter this completely new era of business. Thank you so much for hanging out with me for this explainer. Keep learning, stay focused, and I'll catch you on the next one.